Welcome to this Masterclass Explainer. I want you to completely shift your mindset for a second. Think of yourself not just as a student sitting at a desk, but as a master architect. Seriously, when you design a building, you don't just throw a bunch of loose bricks at an empty plot of land and cross your fingers hoping they somehow stand up, right? Of course not. You need a highly detailed blueprint. Every single pillar, every structural beam, every mathematical masterpiece has a very specific, undeniable purpose. And that is exactly the energy, the focus, and the precision we are bringing today to conquering the Cambridge Mathematics Syllabus 9709. And specifically, we're targeting topic 4.1, Forces and Equilibrium. Now, whether you are currently building your foundational skills in syllabuses like 0580, 4024, or 4040, or maybe you're stepping up to additional math in 0606 or 4037, or you are already tackling the advanced mechanics of 9709, mastering the core concept of the vector sum 0 is absolutely essential. It is non-negotiable. This specific topic appears in literally every single examination series. It is a favorite for examiners. And today, I am going to show you exactly, step by step, what the principal examiners are secretly looking for so you can construct the absolute perfect answer every single time you sit down for a paper.
Okay, let's dive right into the deep end here. Why do so many incredibly hardworking, smart candidates consistently bleed marks on forces and equilibrium questions? To understand this, let's look at two very classic student archetypes that examiners see year after year. First up, we have Alex. Now, Alex is what we call the overloader. When faced with a complex mechanics problem, Alex just totally panics. Their strategy is to dump every single raw mathematical fact they can possibly remember right onto the page. They're frantically writing down Newton's laws, random trigonometric identities they memorized, literally everything they can think of, but there is absolutely zero structural analysis connecting any of it. It's just superficial breadth without the required analytical depth. It's a mess. Then, on the other end of the spectrum, we have Sam. Now, Sam actually knows the math, but Sam rushes. Sam is always watching the clock, so Sam skips right over the command words, totally ignoring whether the question specifically asks to show that, or calculate, or evaluate. Because Sam completely misses the specific structural requirements of those command words, they answer a question the examiner didn't even ask. The result? Both Alex and Sam end up with an exam paper that is just completely covered in red ink from the examiner. We are going to make sure that doesn't happen to you today.
So here is our structural roadmap for today's explainer. First, we'll cover the core theoretical principles. Second, we'll break down the method mark strategy. Third, we're going to do a fast-paced interactive workshop. And finally, I'll reveal the top examiner warnings. Let's get right into it. Section 1, Core Theoretical Principles. We have to start by laying the theoretical foundation before we can build the house.
In Cambridge Mathematics, you have to understand that the assessment framework heavily prioritizes analytical depth over superficial breadth. They don't want a million random facts, they want deep understanding. So let's talk about equilibrium, specifically a vector sum 0. This is formally defined as a state where the resultant of all forces acting on an object is exactly 0. But crucially, getting to that answer requires systematic analysis. Principal examiners consistently report in their feedback that candidates confuse key terminology all the time. Listen, you absolutely cannot just write forces cancel out on your paper and expect a mark. That is way too casual. You need to demonstrate the theoretical architecture behind that statement. You must clearly show that the sum of the resolved components in any given direction, and we are usually talking about the x and y axes here, is precisely 0. Defining this core term immediately and accurately in your own mind sets a rock-solid foundation for all the complex algebraic and trigonometric calculations that are going to follow. If the foundation is weak, the whole building collapses.
And honestly, this brilliantly illustrates the exact difference between our struggling student Alex and a top-scoring, top-tier candidate. Alex's flawed approach relies entirely on just listing raw mechanics facts. It's completely scattered. It's like throwing paint at a wall and hoping it makes a masterpiece. But the top-scoring candidate does something completely different, and it's highly intentional. First, they use precise definitions. Second, they establish clear causal relationships. For example, they will write something like, because the particle is in equilibrium, therefore the vector sum of forces is 0. Do you see how logical that is? Furthermore, the principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher marks. The top candidate doesn't just do forces, they integrate their knowledge of trigonometry, their algebra skills, and their geometry principles directly into their forces analysis. They build a complete, cohesive, undeniable mathematical argument that the examiner has no choice but to award full marks to. Section 2, Method mark strategy. This is where we talk about transforming your raw thought process into guaranteed, quantifiable points on the board. So the absolute most crucial point here is exactly how you structure your working. Top students use a specific blueprint. We call it the PEAL framework. Point, evidence, explanation, link. A lot of students think essay frameworks don't apply to math, but trust me, even in mathematics, communication matters immensely. First, you make your point. You're explicitly identifying the equilibrium state. Then you provide your evidence. This is where you extract the exact mathematical data from the text and tables provided in the question. Next, you offer an explanation. You are executing the mathematical analysis with perfectly clear step-by-step working. And finally, you link it back, drawing a solid, evidence-based conclusion that directly answers the specific command word in the prompt. It is a foolproof structural masterpiece for your exam. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, so once you have that PEAL mindset locked in, you need to apply it using a highly standardized sequence for systematic processing. Think of this as your literal step-by-step instruction manual for every question. Step 1, identify the key elements from the complex diagram. Don't just glance at it, really pull it apart. Step 2, apply the relevant principles, which usually means resolving your forces horizontally and vertically. Step 3, execute the analysis with incredibly clear working and proper mathematical notation. Listen to me. This is exactly where your method marks live. If you hide your working, you lose these marks. Step 4, verify your results. Does the math actually make sense in the real world? Step 5, present the information following strict Cambridge conventions. This means using proper headings, the correct terminology, appropriate formatting, and clear annotation. Clear working and proper formatting are not just optional, nice-to-have things. They are the literal, load-bearing pillars that secure your essential process marks, even if your final calculation goes slightly awry.
And guys, this right here is exactly where our second student, Sam, completely goes off the rails. It is all about command word decoding. Sam constantly loses marks by rushing through the text and treating a word like evaluate exactly the same as the word state. That is a massive error. Mastering the command word means extracting the relevant data and then selecting the exact right analytical framework for that specific word. If the question explicitly says show that, you must provide every single logical step of the vector sum zero proof. You absolutely cannot skip algebraic steps in your head because the final answer is already given. The marks are entirely for the journey. If the prompt requires comparative analysis, you must identify similarities and differences using clear comparative connectives, and you have to support every single claim with numerical evidence. You have to speak the examiner's language.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IJC to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IJC and turn on all notifications so you never miss our weekly exam strategy sessions. Now, back to our strategy. When you successfully decode those command words accurately, when you apply the PEAL framework consistently, and when you follow that 5-step standardized sequence, you completely unlock your 100% mark potential. These presentation conventions and theoretical foundations literally guarantee maximum marks. And why? Because you are handing the examiner absolutely everything their marking rubric demands on a silver platter.
Section 3, Interactive Workshop. It's time to stop listening and start doing. We are putting this theory into actual practice right now.
Okay, challenge 1 is the data scan. Imagine we have a 60-second visual timer running on the screen right now. I want you to mentally extract the core mathematical trend from the complex forces data source we're looking at. The clock is ticking. Look really closely at the angles provided. Look at the magnitudes of the forces. What is the fundamental relationship happening right here to maintain this state of equilibrium? Are the horizontal components pulling equally in opposite directions? Are the vertical components perfectly balancing the downward weight? Data interpretation skills are absolutely critical in Syllabus 9709. You must be able to quickly and accurately extract data from messy texts and chaotic diagrams, interpret those hidden relationships, and immediately prepare to draw evidence-based conclusions. 3, 2, 1. Time's up. If you looked at this and immediately identified that the sum of the upward vertical components must exactly equal the downward force for the vector sum to be 0, you are doing fantastic. You are right on track. Let's keep the momentum going and jump straight into Challenge 2, Find the Flaw. I'm going to read a sample paragraph from a mock exam.
The forces acting on the particle are 10 newtons and 15 newtons. The sum of the forces is 0, so it is in equilibrium. Okay, where is the fatal flaw here? Which specific sentence loses the mark? I'll give you a second. Think back to what the principal examiners noted about comparative analysis and extreme precision. Do you have it? The flaw is the massive lack of specificity and the completely missing comparative connection. The answer utterly fails to state in which direction those 10N and 15N forces are acting. It's too vague, and it entirely fails to use comparative connectives to mathematically show how the horizontal and vertical resolved components actually cancel each other out. It's basically just an unsupported assumption, a guess, and Cambridge examiners will brutally penalize it. You need to write a perfect, structured Peel paragraph if you want to secure that mark safely.
Section 4, Examiner Warnings. This is the goldmine. These are exclusive insights extracted straight from the official principal examiner reports.
Let's bluntly outline the top 3 exam mistakes made year after year in paper 9709 regarding forces and equilibrium. Number 1, using the wrong approach for the context. This is the absolute classic trap. This happens when you try to apply a massively complex analytical framework to a very simple equilibrium context, or vice versa. It wastes time and loses marks. Number 2, format and presentation ignored. This is when students get sloppy. They forget to check their formatting, leaving out really clear annotations or failing to use correct mathematical notation. Do you know what happens? They bleed method marks, even if their final number is right. Number 3, non-specific answers. As we literally just saw in our interactive workshop, generic, lazy answers that completely fail to use evidence-based reasoning specific to the exact context of the question will always, always fall flat.
Now, I need to bring your attention to a critical examiner alert. Candidates consistently confuse key terminology. The absolute strongest directive from the examiners is to always, always define your terms before using them in extended mathematical responses. If you are going to base your entire calculation on the fact that an object is in equilibrium, you need to explicitly state early on that this means the vector sum of the forces is 0. Use your comparative connectives properly to explain that. By establishing these definitions right out of the gate, you immediately prove to the examiner that you genuinely possess that higher cognitive domain of knowledge and understanding, well before you even begin the messy work of application and analysis. It's a massive confidence signal to the person marking your paper.
Now, I know that under intense exam pressure with the clock ticking, your mind can just totally go blank. It happens to the best of us. So we've created a powerful memory hack acronym to help you instantly recall all the necessary factors affecting vector sum 0 equilibrium, even when you're stressed. Just remember the word FORCE. F stands for framework selection. Take a breath and choose the right analytical approach before writing anything. O stands for organize your data. Carefully extract every number and angle from the texts and diagrams. R stands for resolve your components systematically. Break everything down into X and Y. C stands for calculate. Do the math with incredibly clear working and appropriate formats so you get those method marks. And finally, E stands for evaluate. Check your results and present them with proper headings and correct terminology. Literally memorize this. Write FORCE at the top margin of your page the second you sit down for the exam.
Let's summarize everything into the ultimate mathematics success blueprint. If you actually want to see the progress bar of your mark potential hit 100%, you must religiously follow these 3 rules. Rule 1. Command word decoding. You have to know exactly what framework is being asked of you. Rule 2. Peel framework application. You must structure every single mathematical argument logically so the examiner can follow it. Rule 3. Time management matrix. Don't rush like Sam and miss the point, but don't overwrite and panic dump facts like Alex. Master these 3 rules, and I promise you master the exam. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, AC Exams, at @ACEXams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @ACEXams_IGCSE and click that bell. Don't let another exam pass you by.
Finally, I want to leave you with this incredibly powerful insight pulled straight from a principal examiner themselves. Top candidates question assumptions, consider perspectives, and justify decisions with evidence. That right there is exactly how a master architect builds a structurally sound, completely bulletproof exam answer. You now have the exact blueprint for mastering the vector sub-zero. So the question is, the next time you look at a highly complex diagram of acting forces on an exam paper, will you just see a chaotic jumble of lines and angles, or will you see the underlying mathematical architecture just waiting to be solved? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.